Alright, hi everyone. Welcome to this session right after lunch. I hope you had a good lunch. So the next 45 minutes we're going to talk about networking on the Azure Platform as a Service offerings. So how can you lock down and secure your databases, etc. on a networking layer. So my name is Erwin Staal, and I'm an Azure architect and a DevOps consultant from the Netherlands. I live in this beautiful place called Assen, and I work for a consultancy company called For.That. As you could probably guess by the name, we do consultancy kinda in all the Microsoft related technology like Azure, but also the C# stuff, etc., .NET Core. All right, so today we're gonna talk about Azure networking. And so the first question to answer is, why would you bother at all? Why would you want to invest your time in doing some networking stuff on Azure? Well, the obvious reason here is that it allows you to make your services more secure. By default, quite a lot of these services in Azure are accessible all over the internet. And there's various reasons why you wouldn't want to allow that. So I quite recently came across a reason to introduce networking, and that was compliance. So the diagram you see over here comes from the Microsoft documentation on the credit card compliance standard that's out there. So what you actually see here is that all of the important stuff, the data we actually care about, is somewhere on the right in the inner circle of networking. And as you can see, the further we go to the left, there's also quite a few other networking layers there as well. So if a hacker would want to come in over the internet and get to our data, it would have to go through various of these networking and defense layers we've put in place. So it allows us to make sure that our data, the stuff we really care about, we can put it away inside a few networking layers, etc., to defend that stuff from the outside world. And that's exactly what we're going to do today. So our goal for today is to kind of create the diagram of the infrastructure you see here. What I've tried to set up here is that we first of all have an API here on the right. And we want to make sure that only this database over here. We want to make sure that only our API over here is able to access this database. We don't want anyone else over the internet to be able to connect to that database. We want to lock that down to just our API. And I've also created a UI, which is also just an application running on Azure. And we want our API to only be accessible by our UI. And last but not least, we do not want our SQL database to be accessible by our UI. Just our API should be able to access that SQL database. So that's the goal for today. And we're going to use various products on Azure to get that going. So first, let's look at the basics here. It all starts with a virtual network in Azure. And a virtual network allows you to group and thereby separate your resources from the other resources you might have, or from Azure in a whole and the internet, etc. So we can create a virtual network and put stuff in it. So for example, your virtual networks or your databases or your Azure App Services. You can put them in a network and thereby make them more secure. So as you see in the diagram over here, we can create a virtual network which has an address space. And inside of that virtual network, we can make segments using what we call a subnet. So we can have a virtual network that has one or more of these subnets. And on the outside of the virtual network, we can enable something called a network security group, which allows us to set rules on the traffic that's allowed to go in and go out of our virtual network. So it's kind of a firewall there, as you will. So you can create these virtual networks in Azure using all the private IP ranges out there defined in the RFC. So that's the 10 range, the 172 and the 192 range. That's probably quite familiar to you. The 10 one is especially being used in larger enterprise environments as it gives you the most IP addresses to use. So when you create a virtual network on Azure, then the smallest segment you can actually use is a 29. That would normally give you 8 hosts, 8 IP addresses. But in Azure you only get 3 because Azure reserves 5 IP addresses out of each virtual network for its own use. So as you can see, there's 5 IP addresses listed down there, and they're used by Azure by default. So you need to keep that in mind. You don't get the whole space you define. All right, so let's go into the Azure portal, and let's have a quick look at how we can create one of those virtual networks. As you can see, I've been doing a bit of preparation here. I've already created a few resources in the portal. Let me blow that up a bit. And as you probably remember from the diagram I showed you before, we are having a UI, and this UI connects to an API, and through that API it gets a list out of the database. So this is my UI, and then we have an API that simply returns the values in a JSON string, and which is being used by the UI then. And this stuff comes from the database. So this is what I'm currently have in place. So if you look at the resources I have here, then you see there's an API, there's a UI, and there's also the database and database server down here. And I already created a virtual network for the UI application, but I haven't done that for the API. So let's go do that right now. Click Add, and we search here for the virtual network. And we hit Create. And it will obviously, first of all, ask us for a name. So we're going to call this the demo API virtual network. And we have to specify the location where we want to have this. And this is quite important, the location you pick, as we will get to later on. So the next step is to define the address space we want to use. So in this case, I'm going to use the 250, and let's pick a 24. That should give us more than enough IP addresses for this particular demo. So in this virtual network, I'm going to create a subnet, and I'm going to create 2 of them here. So the first one I'm going to call default, and I'm going to give it the 26 segment. And as you can see here, that leaves us with 59 IP addresses instead of 64, because of the 5 that's being reserved, as I mentioned before. So we're going to add a second one, which we're going to use for the web apps later on. And later on, I'm also going to explain you why we need a second one and why we couldn't just use one of these subnets. We will see that when we start working on the Azure App Service. So one thing to note here is that I'm going to create this subnet for the Azure App Service. And when you create your virtual network and your subnets, you need to think about how big you create them. Once there is stuff in your virtual network or in your subnet, it's quite hard to extend it. So it's quite hard to make it larger. Most often that's even just impossible, you can't do that. So you have to think about the size of your virtual networks before you actually create them. And if we look at the Azure App Service that we're going to add to this particular subnet later, then there's an extra rule to think about. And that is that an app service can scale out to, for example, 20 instances. But when an app server does scale out, it temporarily needs twice as much addresses as you have instances. So for example, if you have 20 instances running and you're going to scale it out, you're going to need, for a small amount of time, 40 IP addresses. That's how it works. So if you're going to create a subnet for an Azure App Service, you need to think about it and you need to make it large enough to handle the scaling there as well. All right, now we have added the 2, and the rest of the options here on the subnet and virtual network are going to be default. So I'm just going to hit the create button over here, and my virtual network and my subnets will be created. That's often an operation that, as you can see, is quite quick. So that has already been done for me. So that's how easy it is to get started with a virtual network. Let's get back to the slides to talk about the next service, the next networking service in Azure we're going to use. And we're going to work from as securing the database up to securing the API and to the UI. So we're going to try and lock down the database first. And we're going to do that using the Azure Private Link. And the Azure Private Link allows you to access an Azure Platform as a Service over a private endpoint. So that means that you don't have a public IP anymore on your Azure PaaS service. So if you look at a SQL database, you would normally access that over a public connection. But if you add a private link to it, you can lock that down to just the IP address that your private link will get. So you add that private link to your virtual network. So the Azure SQL server actually gets an IP address that comes from your subnet, as we will see later on in the demo. And then it will no longer be accessible over the internet. It will just be accessible from within your virtual network. So the Azure Private Link is available on quite a lot of services in Azure already. It's quite a big list here, and most of them are general available. There's a few which are still in preview. And one of them, which is in preview, is the one on the Azure Web App. So you can't start using them on an Azure Web App, but it's still in preview. And another thing to note there on the Azure Web App is that if you want to use a private link, you need to be in the premium app service plan. So if you want to use a private link, that's going to be an expensive option right away because you need to go to the premium tier. That's something to keep in mind there. All right, let's go back to the Azure portal and let's head over to our SQL server to add this private link. So first we're going to here in the Azure portal to the firewall and the virtual networks blade. This is where you can do some firewalling stuff on the database. And there's two changes here that we're gonna make. First of all, we're gonna set this deny public network access to yes. We don't wanna have a public IP anymore. We only want to be able to access this database over our private endpoint. So we're gonna set this to yes, please deny public access. We're also gonna set the allow Azure services and resources to this server to no, because we don't want to whitelist the whole entire Azure anymore to our SQL database, to our SQL server. So let's hit save. And updating these firewall rules most of the time takes a while. So if I would now go to my API and I'm going to refresh here, you're gonna see it still works. It often takes 1 to 5 minutes for those changes to become effective. So keep that in mind when you start working with this. It might take a while before those firewall rules get in effect. Don't let you get lost by that. So next we're gonna actually add the private endpoint, and we can do that here on the private endpoint connection blade. We can simply hit add the private endpoint, and let's make sure we do it in the right resource group, and let's give it a name. So we're gonna call it SQL Private Endpoint. And again, I'm gonna choose Western Europe here since that's where all of my resources currently live. And in the next step, it asks us to select a resource we want to connect to this private link. And today that's an Azure SQL server. So I'm gonna go to SQL server. And then you will have to select the resource that you actually want to connect to this private link, which is the database server that I have. So it's good to see here that's actually about the SQL server and not about the SQL database. So you connect your private link to the server, meaning that every database that's on that particular server will be accessible over this particular private link. So we've been selecting that. Let's go next on the configuration. The next thing we have to do is add it to a particular virtual network. And here we're gonna pick the API virtual network that we just created, and we're gonna select the default network as we're going to use the web app one for the web app, the API later on. The next thing down here is the question if you want to integrate with the private DNS zone of Azure. And yes, we want to do that because that allows us to reach our database later on just using the regular connection string you've always been using. So you're not going to connect to your DB on the IP address. You're just going to use a regular connection string, and then the Azure Private DNS Zone will make sure of the translation there. So we set it to yes, and it will create a new private DNS zone for us. So let's hit review and create, and let's have this private endpoint being created. This is again an operation that does take some time. So we're gonna have that going, and in the meantime we'll have a look at another Azure service that we can use to come to the goal of today. All right, so the next thing we want to do is make sure that our API is actually able to go to that database over the private link. To do that, we need to add the app servers to the virtual network. And to do that, there is a thing called the App Service Feenet integration, which is a quite new offering on Azure. And it allows you to have your app server join a virtual network. And what's important here is that the app service will only use that virtual network for outgoing traffic, so for egress, not for ingress. We'll look at that a bit later. So it allows your app service to access resources that are in that same Feenet in the same region. That's important. If you use this regional Feenet integration, you can only reach into endpoints that are in the same region. That's important. You do need a standard or premium fee to app service plan. So again, this doesn't work on the basic one or the service one, for example. You're gonna need this standard or the premium one. So it does add a bit of cost there if you weren't on one of those plans anyway. And because you then have your app service in your virtual network, it allows you to block outgoing traffic using a network security group. So you could also make sure that your app service, your API, isn't allowed to connect to anything else than this particular database. All right, let's go into the Azure portal and let's see if and how we can do that app service integration. So let's go into our API, our app service, and let's go into the networking blade. And then we're going into the Feenet integration part and hit configure. And here we can say add a Feenet. It will then show us the list of virtual networks it's in this subscription. And we're going to pick the API one because that's obviously in the one we can use. So the other option here is the other regions. I already mentioned that there's the app service integration with the regional Feenets, but also you can also integrate that with Feenets in other regions. But that does require a bit of a different type of integration, a bit of a different type of virtual network gateway configured, etc. So today we're going to use a regional Feenet integration. So we're going to go for the API one that I just created. And we have already created the subnet, so I can just select it from this list. And as you can see, I can't even pick the default one here because this app service integration requires a subnet that hasn't already anything else in it. And that's because what's happening here actually is that you're kind of giving this subnet to the Azure App Service and say, here is some IP address or some range that you can use for your particular service. So that's the reason why you can't mix up with anything else. It's going to delegate this particular subnet to the Azure App Service you put into it. So it needs to be an empty one, and you can't afterwards add anything else into the same one. So let's hit OK. And it takes a little while, and you see that we now have a Feenet integration. So let's see if our database is still working. It is. So that's good. And there's one way actually on how you can check if this connection is actually doing what it's supposed to do. And that is by going to the console on the Azure App Service. And we're going to use a command here. I already typed it in so you don't have to see me type all the time. So what we can do here, we can use the name resolver utility that's on Windows by default. And we can say do a resolve on the address, the full qualified domain name of the SQL server. So as you can see, I'm just going to connect to the domain name or the DNS name you would normally do. But this time, if everything goes all right, you will see that I actually get a 10.250.04 address back, and not the regular public IP address, which is somewhere in the 13 range, if I'm correct. So you can see that it actually now works. It's connecting to that particular address over the private link, and I'm using that to connect over a private IP address. There are two settings, however, that I have set up in the configuration section over here. And I've already done that beforehand, so you don't see me typing, etc. And we can go over it quite quickly. But there are two settings here that you need to be able to get this running. So the first one here is the website DNS server setting. And you do that, and you give it the IP address of the Azure DNS server. You can find that one in the documentation of the Azure App Service Feenet integration. I can share the link later on. You need to set this one because, as you remember, when we created the private link on the SQL server, we also created an Azure Private DNS zone, which holds the record, the DNS record of our database, and connects that to that private IP address. And to be able to use that private DNS zone from an Azure App Service, you need to set this particular setting. Otherwise, your app service will ignore the DNS, the private zone, and it will be unable to find your private IP. So you have to set this particular setting. The second one is the website Feenet root all setting, and we set that to 1. It can obviously also be set to 0. By setting it to 1, we're telling Azure that we want all of the traffic that's going out of my Azure App Service to go through my virtual network. By default, only private IP addresses, so the 3 private ranges I showed you in the beginning, only those 3 addresses will be resolved, or the traffic to those addresses will go through the virtual network, and all the public resolvable stuff will still go through the old normal route. And by setting this one to 1, we ensure that all the traffic that's going out of my app service will actually go through the Feenet, which then allows you to also block whatever you want, but it's also needed to make the private link here work. So that's 2 settings you need to keep in mind to add to your Azure App Service if you want to work with the private link stuff. I kind of think that they might make this a bit easier because it's something you need to know to get this working. It's in documentation now, so that's a good thing. It wasn't there when I started out with this whole private link stuff, so I had to figure it out through multiple blog posts. But at least it's in the documentation now, so that's good. All right, so what we have so far is that we have a database that's only accessible through a private IP address, and we have an API that's been integrated with my virtual network, and that's able to connect to my SQL server over that private IP address. So that's good, that's nice. The last thing we need to do here is make sure that also my UI can connect to my API, and that we can make sure that the UI, the interface, is actually the only thing that can connect to my API. So let's go back to the slides and look at the Azure service that we're actually going to use to get that done. And that is what we call the Azure Service Endpoint. And what it does is that it provides a secure and direct connection to an Azure service. So we want to have our app service connect to a SQL server or to our API later on. So that means that we're going to add a service endpoint which connects to the Azure App Service to the subnet of the UI. So that allows the UI to go through a service endpoint to other app services. That's basically what you're doing. What you're doing there is that you are giving it a new route, a new way to connect to the Azure App Services. And that makes sure that traffic actually stays within the Microsoft network. Normally, if you would connect from an app service to another one, you would actually go over the public internet. But by adding a service endpoint to that virtual network, traffic will be routed through the Microsoft network and won't go outside. So that's more stable, it's more performant, and it's also more secure. And on the other side of things, we can then actually lock down the API to just this particular subnet that our UI is in, because the UI uses this service endpoint. We will look at how that looks from the API perspective later on. So a big difference here between the private link and the service endpoint is that we still use the public IP address of the thing we connect to. So the UI is going to connect to the API, and although that's going to stay in the Microsoft network, it's still going to connect on the public IP address and not on a private one from the subnet of the API, for example. So that's the difference there. That works a bit different. So how it actually works is that when you add a service endpoint to, in this case, in the image below, a virtual machine, then if you look at the effective routes for that virtual machine, you will see that there's an actual extra record inserted there that says that all of the IP addresses, all of the traffic that wants to go to this 1369 range needs to stay within the Azure network and needs to go over the service endpoint. So it's actually adding some effective routes to your list of routes, and that will make sure that your traffic will go through the Azure internal network instead of going over the public internet. So these private endpoints are available on quite a lot of services as well. Most of them are actually general available. Just the Azure Container Registry is not, but that will probably not take too long anymore. So let's have a quick look at how we do that integration. So I'm gonna go back to my UI, which lives over here. We're gonna do that same network integration stuff because to be able to go over a service endpoint, it needs to be integrated with a subnet as well. So we're gonna pick the UI here, and we're gonna pick the web app here. So let's hit OK, and it shouldn't take too long, and that's been configured. Okay, so I haven't done anything else here yet than what we did on the API already. But what I did do before we start this demo is that on the subnet, on the web app subnet in the UI virtual network, I added the Microsoft.web service endpoint. That's an operation that can take up to 15 minutes. So I did it before, so that would actually work. So I added the virtual or the service endpoint here already. So what that does is that if my UI now wants to connect to another Azure app service, that will go over the service endpoint and stay within the Microsoft network. So we haven't locked down the API yet. That's to come, but we have made sure that the UI actually goes over the service endpoint to the API. So that's good. That's nice. So let's go back to the slides and have a look at how we can actually lock down the API with the information we currently have. And to do that, we're going to use something called access restrictions on a web app. And that allows you to define a priority ordered allowed denied list that controls the network access to your app. So that basically means that you can have a list of stuff that is allowed or denied to go to your app service. And we're obviously going to allow the UI to access the API, and we're going to deny all the other traffic here. You can do this allow or disallow based on IP addresses or on an Azure Virtual Network subnet, which is obviously what we're going to do here. But you could also be adding just a single IP address to, for example, just allow your home address to be able to connect to a particular web app and deny the rest of the internet, for example. So let's dive into what that looks like. We're gonna hit back to my API one last time. We're gonna go to the networking blade again, and then we're going to the access restriction option, which is down here. We're gonna hit configure. And as you can see, there's currently one rule already added by default, and that says allow all. So all traffic is actually allowed into my web app. So we can hit add a rule here. You can give it a name. So this is actually my UI, so let's call it UI. You can give it a priority. So if you have multiple rules, you can play with that. And here on the type, we can choose for IP4, IP6, or the one we're going to need today is the virtual network. So I'm going to hit that one. And I'm going to pick the UI virtual network because the web app lives in UI1. And then I get to pick the subnet that I want to allow access to my API. So let's do that. Let's hit add. And as you can see, it's been added, it's been enabled. And what also happened right away is that now that I've added one rule, the Azure portal added a second one, which now says deny all. So only my UI subnet is now allowed to go to this one. And and I'm not from home, for example, no longer. So if I refresh this one, you will get a forbidden error, which is good because that's exactly what we want. But if we then refresh this page, and everything should still work. So my UI is still able to go to the API, but I've locked that down to just the subnet of that UI. So that's pretty cool. All right, there's a second list here, second deny allow list, and that's for the management part of the Azure App Service. So for example, you probably all know the Kudo console, and you can also lock that one down, which is good advice anyway. So there's a separate list to do to that one. You could also hit this checkbox here to say you want to use the same deny list as we have over here. So that's kind of, for the demo at least, as far as I want to go today. We create a UI which can go to an API. That API is restricted to just a UI. And we have a database that's only accessible to stuff in that particular subnet. So that's pretty cool. You've secured and locked down those services to just the right services that actually need access to them. But you might be asking then, how am I gonna connect to the database, for example, from my developer machine, or go to connect to the API to do some testing, whatever. So there's other options to, from an external point of view, get into that virtual network as well. And that's by using a VPN gateway. That allows you to set up a VPN connection into that virtual network to get access to it. And so there's actually two types of virtual gateways that you can use. You could connect it between the Azure Virtual Network and your on-premises location. So that could be your office, for example. But you can also use these gateways to connect between two virtual networks in different regions. So there's a few options here. First of all, there's the site-to-site connection, in which you connect your office, for example, to one virtual network in Azure. That's what we call site-to-site. Then there's multi-site, where you have multiple offices and connect them into the same virtual network in Azure. So there's also the Feenet to Feenet one, where we can connect multiple subnets, virtual networks in different Azure regions with each other over a secure line. There's also the express route option. So that one is a dedicated line, private line just for you. That's often a bit more performant than the standard gateway, which goes over the internet. And it gives you a bit more performant, more secure line. So you could use that as a default line. It could also be your backup line, for example, to have two lines, two connections into the Azure Virtual Network. And last but not least, there's the point-to-point VPN, which is probably the most simple one. You can use that to have a client machine, so that could be a mobile phone or a desktop or a laptop, connect to your VPN gateway directly. So in the other options, you will need a networking device to make the connection for you to Azure. Here you just have a piece of software running on the client devices and have that connect into your Azure Virtual Network. And there's 4 different ways today on how you can secure that. First of all, you could use a certificate, which you then have to share, obviously. You could use your Azure Active Directory accounts, use the Radius protocol, or go for OpenVPN. So there's a few options here that you can pick to set this up. So there's also another option if you want to do the virtual networking stuff, the VPN stuff, and that's the one we choose to use at my current client. And that's that there's also a few third-party solutions to solve this problem. And we went for one by Cato Networks. And Cato offers a suite of services to you, amongst one of them is being the VPN connection that allows you to connect into Azure. So it's actually a point-to-site, point-to-point connection. I have a VPN client installed on my machine, and that client connects into the Cato network. So there's nearly 50 what they call a point of presence in the world to which my client can connect to. So my client finds the closest Cato network entrance that it can find and connect to it. So after that, after I've been connected to the Cato network, my traffic into Azure will go over the private backbone of Cato. So that's again a more performant, more secure line than just going over VPN over the public internet. So it finds a point of presence, and over that connection, I will be routed into Azure. And in Azure, we have something called a next generation firewall. So if I dial in using VPN, I will go over the Cato network, go through the next generation firewall, and end up in my virtual network. And that ensures that I have a private connection, and also ensures that every bit and byte, the traffic that goes over that connection, is actually firewalled and been scanned by that next generation firewall for malicious content, for example. So that's pretty cool. It's obviously a bit more expensive option than one of the built-in stuff in Azure, but it also does give you more advantages. One of them being that we now have a few static IP addresses that we can use on these VPN connections. So if I dial in using my VPN connection, I always get the same IP address. So I can use that IP address to whitelist me on particular services. So for example, since a few months now, you can actually whitelist your IP on GitHub to make sure that only you can access your repositories on GitHub. So you can whitelist your IP to make even that a bit more secure, even if it's not living in Azure, which is the case for GitHub, obviously. So it has a few benefits there as well. You also get a nice shiny portal, which allows you to manage your VPN connections and your network, see the amount of traffic that's going through it, and also do a bit of configuration like, I don't want Google Hangouts traffic to go into Azure or to go over the VPN altogether. So you can make a bit of a configuration there as well. So that's pretty cool. All right. With that, that's the end of what I wanted to share with you today. But before we go to my last slide, we obviously want to thank the sponsors that made this day possible. I hope you had a blast so far, and I hope these sessions after me are going to be very inspiring as well. So thank you for listening here. If you have any questions, you are free to contact me anytime. It's my Twitter handle over there, and you can also find me on LinkedIn, for example, if you have questions after the session. So thank you.
Thank you, Arwin. There are no questions in the Q&A chat, so thank you again for joining us.
All right, you're welcome. Bye-bye, guys. Have a nice day.
Bye, thank you.